In this video, in the Universe Sandbox simulator, I'll combine all the rocky planets of the solar system, Mercury, Venus, Earth, and Mars, into one superplanet. We'll run 2 different simulations and see what kind of planet forms in the end. Earth is the largest and most massive planet among the rocky planets, so it will absorb everything, roughly speaking, and the merger of all these planets will take place in Earth's orbit. And now all 4 planets have come together. In the first simulation, I'll combine all these planets without any loss. To do this, I'll turn off fragment formation and temperature modeling. This way, we can combine all the matter of Mercury, Venus, Earth, and Mars into one superplanet without losing a single piece. I've opened Earth's main characteristics. Here you can observe how the mass and radius will change. You'll also be able to watch the changes in the day and year on Earth. Starting the simulation, well, first of all, we see how Mars is changing. Something's happening to it here, and Earth has started flooding here, like seriously in Africa. And South America is also seriously flooded. Well, here, Mercury is the first to collide with Earth. I'll do it like this, so we can see everything in more detail. And here, a tsunami sweeps through, everything is flooded. Well, that's to be expected. Earth's mass is already growing. And that's it. Mercury is completely absorbed by Earth, and as we see, Earth's mass increased by 6% because of this, while the radius only by 1%. And here, at the collision site, something like this is happening. Mars will be the second to collide with Earth. Mars is stretching out like this, and it has begun its collision with Earth. And that's how this merger happened. And because of this, Earth's mass is already increased by 16% and the radius by 4%. So Earth has absorbed Mercury and Mars. Well, now Venus is approaching. Venus will collide with the other side of Earth. The merger of Venus and Earth has begun. And here we already see how gases from Venus have started reaching Earth. And Venus somehow, at the end, entered Earth very quickly, quite unusual. And we see how, most likely, carbon dioxide from Venus's atmosphere has started covering Earth. I'll light up Earth from all sides. And we see this situation on our planet. I'll speed up time more. And here you see how Earth's atmosphere is being completely pulled in by these gases from Venus. This is certainly incredible. And after some time, Earth's atmosphere was completely covered by these impenetrable clouds. In the end, Earth's mass increased by 98%. Our planet became almost twice as massive, while the radius increased by only 22%. And the day on Earth is shortened significantly, lasting just under 7 hours. And a year on planet Earth is now 327 days. Now, in the simulation settings, I'll bring back the fragment and temperature modeling. Now let some time pass, the temperature stabilize, and you'll see the final result. Time has passed, Earth's appearance hasn't changed, it's still covered by that same thick atmosphere. As a result, the average temperature is 674 degrees Celsius. The pressure on this Earth is 125 atmospheres. Well, there's almost no chance of life. I'll hide the atmosphere and clouds, and here we see the Earth's surface. It's all completely molten like this. See, it looks like it's burning like magma, and it's still covered with water on top. This, guys, is water. There are some strange areas here at the top and bottom. Maybe it's a simulator bug, but anyway, it is what it is. So everything is flooded, there are no continents here. So that's how it is. Well, if we look closely at the atmosphere, I notice one thing. The carbon dioxide concentration on Earth has increased significantly to over 91 Earth atmospheres. And there's a lot of water vapor, almost 49 Earth atmospheres. And nitrogen has increased to 4 Earth atmospheres. Well, all of this came from Venus, that's obvious. Now let's compare the new planet with the regular Earth. As you can see, the new Earth isn't much larger than the old Earth, only a 22% difference. But in terms of mass, the difference is almost double. Now it's time for the second simulation. This time, everything will be as realistic as possible. Fragment formation and temperature modeling will remain enabled. I'll collide the planets with Earth at minimum speeds so they don't shatter into pieces immediately, but gradually merge into one planet. And we immediately see the same thing as in the first experiment. Here, Mars is getting covered with this strange substance. On Earth, these floods are happening due to the tidal forces of nearby objects. And Mercury, as usual, is the first to collide with Earth. I've opened Earth's characteristics again. Look at how things are changing here, and now these particles are flying off from Mercury. I'll speed up time. And this time, as you can see, the mass has only increased by 1%, and the average temperature is starting to rise significantly. Next, Mars will collide. Oh, what a collision Mars is causing. Some kind of purple gases are flying out from the planet. This is crazy for sure. And now a powerful collision has occurred. Well, as you can see, many fragments are being ejected into space. So there will be mass losses in any case. And it's hard to say how much mass Mars specifically added with this collision. Well, right now, Earth's mass is only 3% greater than before. And now we already see Venus colliding with Earth. Meanwhile, Venus has completely collided with Earth, and we see a temperature on Earth of over 4,000 degrees Celsius. Incredible. I'll show all the particles again, and this is how the whole thing looks. I'll speed up time. This is incredible. Look at what's happening there in the fire. Crazy. If we zoom out even more, this is the situation. Oh my gosh, what just happened? Was the Earth destroyed or what? Oh my gosh, I didn't expect that. Guys, the Earth was actually destroyed. Let's try it one more time. Starting the simulation. Well, this time the Earth still exists, so that's good. This is what it looks like now. It's really quite unusual. I need to fast forward time some more. Time has passed, everything's stabilized, and this is what our Earth looks like, hiding the atmosphere and clouds. And check out the surface of our planet. It's like a huge crater or something like that. There are some smaller craters here, and there are these impact marks on the Earth. You can see the old continents of Earth, but that's just how this simulator works. They don't disappear, but in reality, not a single trace of those continents should have remained on our planet. In the end, the mass of this Earth increased by 73%. Yes, the value here is lower than in the first experiment, but like I said, there were fragments and losses, and the radius only became 18% larger. A day on Earth is now just under 7 hours. It's a similar situation here as in the first simulation. The year on Earth has also shortened to 352 days. I'll turn on the clouds, and the average temperature on Earth is 602 degrees Celsius. The pressure is lower this time, 55 atmospheres. Now I'll turn on the atmosphere, and it's mostly carbon dioxide, almost 63 Earth atmospheres. If you switch to percentages here, it turns out that carbon dioxide makes up 100% of the atmosphere. Unbelievable! This time there's no water on Earth left, and there's no chance of life on an Earth like this. And we can even see that after the collisions, the moon's orbit around Earth became more elliptical. Now at certain points, it gets very close to the Earth. At its closest point, the moon approaches the Earth at 258,000 kilometers. And this is what the Earth's orbit around the sun looks like. As we can see, Earth's distance to the sun has decreased slightly to 0.98 astronomical units. And you can see many collision fragments orbiting in the inner solar system, creating a sort of asteroid belt that Earth also orbits in. If we hide the atmosphere and clouds, we can see these glowing hot areas on the dark side of the planet. I'm here near Earth and look toward the sun. There's so much dust and gas from the collision that it's like a nebula has appeared in the solar system. That's it. This is the result of merging all the rocky planets in the solar system. If you enjoyed this experiment, please like the video and leave a detailed comment. Thank you very much.